So we've officially deployed the talk. Welcome everybody. Thank you for coming out at 9 a.m. on a Friday morning to the conference. I know that couldn't have been easy, so really appreciate you coming to hear me gab about DevOps. My name, whoops, I just got to get to the right screen here. Cool. Perfect. My name is Clinton Herget. I'm a technical director with Mabomo. You may know us from such Craven marketing opportunities as your lanyards, so thank you for wearing our branding. Really excited to be here at Drupal GovCon. I've enjoyed the theme of the last couple keynotes about sort of personal origin stories, so I thought I'd throw in just a couple slides at the beginning here to talk about who I am, how I ended up in front of you today. I didn't really take the traditional technology path. I was not a CS major. I studied philosophy. And at the risk of dating myself, the only thing I ever wanted to be was a stand-up philosopher. The job market was not great in that in the time around when I graduated. So I learned PHP, wrote a content management system. It was terrible, but it was good enough to get me a volunteer job with this guy, at the risk of dating myself again. And at the time they said, hey, we're working on this real new cool thing. It's called Drupal, and we've got an excellent new version that's about to come out. It is 4.2. And it's really going to revolutionize things. So that was about 15 years ago. Really been with Drupal ever since. I spent about 10 years as a freelancer doing all manner of full stack development. Never got very good at that. But what I did realize was what I enjoyed was taking other developers' broken code and pushing it into production and making it scale. So that's sort of what this talk is about today. But this is not on the engineering track. I'm not going to talk about tools. I'm not going to talk about Jenkins versus Circle CI. I don't really care about any of that stuff. This is not about the how of DevOps, because you can go to any number of talks where somebody like me will stand up and talk about his great development pipeline that he's put together for his team. And that's great for his or her team. But the point is, you have to make the technology fit the people that are involved. And so that's what I wanted to talk about, more the why of DevOps, the philosophy, and what it involves, changing our precepts about how we think about software, how we think about the people involved in making it. So not too many people. I did want to get a quick show of hands. How many people are in a position that they have the ability to make a change that completely ruins a production site, especially on the homepage? All right, a couple. So this isn't going to be a great exercise, but keep your hand up if you have totally hosed your production site. All right, so it's just me. Cool. Nicely done, sir. And then finally, I'm going to keep my hand up here. If immediately prior to totally screwing up your production site, you thought, this change couldn't possibly screw anything up. Okay, so it's just me, which is fine. Ideally, by the end of the talk, everybody's going to have their hand raised to that question. That's ultimately my goal here. Because I think DevOps is about breaking as many things as possible. And that's kind of counterintuitive, right? Because what we hear is that it's about creating more stable software through more rapid development. But in the process, I feel like there's a contradiction at the heart of it, whereby we actually have to break a lot of things to get to the point where we can say those things are fixed. And that's kind of the interesting philosophical contradiction I wanted to talk about today. So, first of all, who are we? We're Mabomo. We've won a bunch of awards, including Best Places to Work. We're hiring, by the way. But what I like a lot about the company is that our three main federal projects are for NASA, US Geological Survey, and NOAA. So if you have a Drupal project that involves literally moving a planet, we're the people who literally do that. So the problem is, though, doing Drupal at planetary scale, it's really hard. By the way, marketing department, that one's for free. And it involves a lot of broken stuff. I can say this before the president of our company comes in, like a lot of broken stuff, okay? But I actually feel like, again, with this contradiction inherent in DevOps, that leads to better resolutions. The more things you break, the more things you can fix. But I did want to say, just a brief disclaimer, don't panic. This is for the benefit of Ken, who's right outside. But when I told him about the topic of the talk I wanted to do, I sent him my slides on Slack, and he says, dude, this is going to terrify people. You can't stand up in front of a room and talk about how Mabomo likes to break things. All my federal clients are going to be blowing up my phone. And I said, I know, right? Cat with heart eyes emoji. I strongly recommend using cat with heart eyes emoji anytime you're having an uncomfortable conversation with senior leadership, because it really softens the blow. And Ken Fang says LOL, which is what he literally says, and you say, hey, Ken, the production site is totally screwed up, and I'm the one who did it. LOL. But this is just to say, don't panic, hear me out. Don't immediately run to Ken and say, hey, your technical director stood up and was really excited about how much you guys like breaking things. Because what I think is important about DevOps is that we change our internal definition of what brokenness means. And we'll get to that a little bit later on, but the two things I wanted to say sort of right here off the top to remember about brokenness. The first is that the natural state of the universe is brokenness, right? We'll get to why in a little bit, but there's no website in the world that's not broken right now. Somewhere in Mountain View, California, there's a team at Google that hasn't slept for 3 days because they're trying to fix some unfixable problem. There's a database administrator whose husband thinks she's dead, and she's surrounded by empty Mountain Dew cans. This is just something that's inherent in the software development process that I think it's important to accept if we're going to be engaging in that process. And the second thing to realize about brokenness is that in order for something to be broken, it has to be observed. And this is where we get a little bit into theoretical physics, which we'll get a little more into later. But the idea is sort of similar to Schrodinger's cat, if you're familiar with that thought experiment, right? You put a cat in a box with essentially a randomizer that will either kill the cat or not. You don't know whether the cat's alive or dead until you open the box, right? And so in that state, it's sort of both alive and dead. You can't confirm that the cat's dead until you open the box. I'm sorry for any cat lovers in the room. Schrodinger's fault, not mine. But broken things is sort of very similar, right? In order to say this is definitely a bug, you have to open the box and discover that that's a bug. But what you've done in the moment of opening that box is you've created the opportunity to fix something. And you didn't have that until you opened the box. So again, this is a little disclaimer before we start. Don't blow up Ken's phone, because I get that this stuff is hard, right? Nobody wants to hear that your site is broken, even though it is. Like right now. You just have to accept that before we move on. And so is Amazon, and so is Google, and so is Facebook, and so is every other software project in the world, because the natural state of the universe is chaos. And that's why we need DevOps, because it's about not pushing back against that idea, but accepting it and living in it and getting excited about breaking things. So, all these talks have to include this mandatory sort of what is DevOps slide, right? Because we're really into jargon, we're really into defining things. This has gotten a little bit better, I think, in recent years as we've sort of coalesced around a definition, but I think I have to talk about it anyway. Because again, I'm not going to talk about tools. I'm not going to say DevOps is when you take Git plus Jenkins plus Selenium equals error-free deployment process. You'll see a few different definitions thrown around, and most of them are this, well, let's talk about this first. The idea of the fish is in water, right? It's two young fish, they're swimming past an older fish, and the older one says, "Water's nice today, guys, isn't it?" And the younger fish say, "Yeah, sure." And then the one turns to the other and says, "What the hell's water?" Right? The idea being that whether you think you are or not, you are in a DevOps process. If you're at this conference, then on some level you are engaging with this thing called DevOps, right? And I think it's important that we look around and realize that we're all swimming through water. So the definition you normally see is a practical one, right? And it's something like, how do we come up with a set of practices to enable teams to deliver software with both speed and stability? And the really important word in that definition is and we'll get to that in just a little bit. I like, again, because I'm a stand-up philosopher, I like to zoom out from that a little bit and say, what DevOps is ultimately, how do we work together to manage chaos? Because the universe is chaotic. It's full of broken things, and accepting that is sort of the first step. So with that in mind, we don't have to guess, right, about what good DevOps is, because the research is there, finally. It was sort of an open question for a long time, but people looked at the problem. They interviewed software teams that were performing well and those that were performing poorly, and we actually now have a pretty good, scientific basis for what good DevOps looks like. Folks who do that, this is a project sponsored by Puppet. They go by the name of DORA, DevOps Research and Assessment. And these are a bunch of really smart PhDs who every year put out the State of DevOps report. So a lot of the conclusions I'm going to be talking about, I basically just pulled from this, but I didn't do the research, but I cited them, so we're good. I find this really interesting because it both confirms a lot of the sort of theoretical backing of DevOps, while at the same time pushing back against some of it. So, in general, here's what they found. That there is actually a direct positive correlation between the speed at which software is deployed and the stability of that software. They divided teams up based on sort of 4 categories, or 4 metrics that were measured. Cool. Oh, all right. Awesome. Let's go back a couple. Here we go. First of all, lead time for changes, right? How long does it take between a new request and that change actually arriving in production. Second of all is the release frequency. How often are those releases being pushed into production? Third is the time to restore service in the event of failure. So how long does it take after a bad change goes into production for that change to be remediated? And finally, the change fail rate. How often do those deployments fail? How often do they have to be rolled back? And what they found is that the teams that are good at these things are good at all of them. So the teams that deploy faster also have fewer bugs in their deployments. The teams that have more stable software are the ones that release more frequently. So there is no trade-off inherent in DevOps. And that is, I think, the first inherent contradiction to get around, is that it's not the act of deploying software with speed or stability. It's that you actually need both. It's impossible, or it's at least very hard, to deploy very stable software slowly, much as it's very hard to deploy really buggy software quickly. Because the practices that we need to implement in our software development processes, for one, imply the other. And again, that's really hard to get our thought around, right? Because the idea of traditional software development would force us to believe that these ideas are in tension, when in fact the research shows they are one and the same thing. Low-performing teams are bad at all of these, and high-performing teams are good at all of them. This is where we get to a sort of brief foray into theoretical physics. So why is that, right? Why is it that the universe is so chaotic, and why is it that deploying software to production is so hard? Well, it has to do with this concept, I think, of entropy, right? Entropy basically is a measure of chaos in a given system. The second law of thermodynamics, if anybody remembers their basic physics, is that the entropy within a given system can never decrease. This is an immutable law of the universe, right? Things get more and more and more complex. They don't get less complex. The sort of basic physics example of this is if you have a bathtub and it's full of lukewarm water, and you take a cup of boiling water and you pour it into the bathtub, that water's not going to be boiling anymore, right? Because entropy basically is heat loss. The process of the universe is a process of losing heat. And this is exactly what it is to deploy software. You are taking something that's running on your local machine, and it's perfect, and then you put it out into the universe, which is much the same as taking water at a particular temperature and pouring it into the bathtub. That's a losing proposition if your metric for success is whether that water remains boiling or not. So part of what the DevOps philosophy is that we move away from this concept of it needs to be perfect all the time, it needs to have zero entropy, into a position where we can say, we get that the universe is made of chaos. How do we best manage that? How do we limit the amount of entropy in the system rather than trying to hold it at zero? And inherently what this means is that the laws of the universe itself compels us to break things as often as we can so that we have opportunities to fix them. Because otherwise, we're never going to open the box and we're never going to discover the bug that's there. And it's appropriate that I've totally lost control of my slides. No? Not going to happen. There we go. If you talk to people who know a lot about chaos, who do a lot of this complicated math, they'll talk about chaotic systems in terms of two levels. Level 1 chaotic systems are things that have tons and tons and tons of variables in them, such that they are very difficult to predict the outcome of, right? And this is something like the weather. No matter how complicated the models get to predict the weather, they're always going to fail at some point. Because the system is so chaotic, they're never going to result in a perfect way to model that behavior. However, making a prediction about the weather doesn't change what's going to happen with the weather, right? So it's actually relatively easy to come up with a model, understanding that it's not going to be perfect. But a level 2 chaotic system is a system in which, again, you have all of these multivariables. It's very difficult to make predictions about it. But the act of making a prediction changes the outcome of the system. And so this is something like a stock market, right? No matter how good your computer model of a stock market is, if you predict a stock is going to go up, and you tell people that you think that stock is going to go up, you are going to change the market and change the variables upon which you made that prediction in the first place. And so I'm here to suggest that the foundational principles of DevOps tell us that software development is a level 2 chaotic system. So think of something like your Scrum Master coming to a Scrum meeting and saying, everybody, we had a great sprint. We did 60 points worth of velocity. Next sprint, we're going to do 70 points worth of velocity because I feel like if we do 60, 70 is a totally attainable goal. Hey, Noah, what's up? However, this is going to change the inherency of the system, right? Now your developers are under more stress because they think, oh God, I've got to pump out 70 points when previously in the last 2 weeks we did 60. That's going to cause them to make more mistakes. That's going to cause your code to be more or less stable and to be delivered more or less quickly. So again, we can't come up with a situation in which we put the entropy of a software system to 0. It's always going to be there. The best we can do is attempt to manage it and keep it under control as much as possible, which is why we need to embrace a DevOps philosophy. So some sources of chaos in software systems, right? First of all, spaghetti code. We're all familiar with this. It's impossible to avoid even in the most well-structured systems, right? Because developers are under a lot of stress all the time to fix things. And that code isn't always elegant. And then somebody else comes along, makes a hack to that code to fix another problem, and then a third developer looks at it and makes a comment that says, I don't know what's going on here, but it works, so I'm not going to touch it. And then 10 years later, somebody pushes that into production, but the package that it relies on breaks. And that's DevOps. So no matter how well we structure our code, this is something that is inherent in the act of software development, and we have to construct a set of processes that allow us to understand that that is not a changeable situation. Second, I like to call the networking gods. This is stuff like, in the middle of your deployment, some network connection between the computer you're deploying from and your production server is going to go down. It's going to happen. A couple months ago, the hosting location for Drush, the drush.far file, which for any technologists in the room is like the one file that you need in every system that's running Drupal, it changed. It had been in the same location on Amazon S3 for about 10 years, and then one day it was gone. That happened in the middle of a deployment. And that's something you can't control. It's a chaotic system that's inherent in the universe. Because every software project depends on thousands and thousands of others that you have no control over that are changing all the time. And we need to develop processes that take that into account, that allow us to say, well, if the location of this package that I've been downloading on every deployment for the last 10 years changes, I need to be able to fix that. But you can't fix it until you know it's broken, which is why we need to break more things. And then finally, of course, human beings, right? This talk is about people in DevOps because in a world with no people, we don't need DevOps. After the machines take over and start harvesting us for our bodily fluids, there's going to be no such thing as DevOps because all code is going to be perfect. This stuff only matters because there are people in the system. And again, you can't just take a set of tools and plop them onto a team and expect that the internal processes of that team are going to improve because you haven't changed the people. Oh wait, sorry, I forgot one. Actually, the most chaotic thing in software development is the Drupal 7 features module. Don't use it. It's real, real bad. So one of the things this Dora group found, as an example of how all this fits together, is the idea that change management, which is an attempt from on high to reduce the entropy in a system to 0, doesn't work at all, right? And this is pretty common, I think, in government software projects, where you have a group of developers, they decide to make a change to a system, they then have to freeze their code and stop, and then this external group of people has to review their code to determine if it's going to break anything when it launches. And this is really funny if you're in software development, right? Because it holds that an external group of developers is going to be able to look at every line of that code and every line of the dependencies that it relies on and determine with perfect accuracy what's going to break as a result. And as we know, this is impossible because of the entropy inherent in the system, right? And yet, this is the process in use at a number of federal organizations. But what the Dora group found is this is actually negatively correlated with software stability. That teams with no change control have more stable software than teams that have to go through this external process. Because manually looking at code doesn't tell you anything. The only way to know if something is broken is to attempt to break it and then see if it breaks or not. And so what it creates is this situation in which you've put everything in a box, you've delivered it, your external CCB is looking at it, and they have to answer the question whether this should be deployed or not, right? But in this situation with the bug in a box, the answer to that question, should we deploy or not, is always going to be no, because it might break something. we're not sure. We can't guarantee that it won't. But that's exactly why it should be deployed, right? Because remember, there's a direct correlated relationship between speed and stability. The more often we deploy, the more often we can see what breaks, and the more often we have opportunities to fix those things. If we're constantly in this limbo of letting other people review our code to only come back and find that it broke something anyway, we're never going to have the lead time to make those changes that we need. So what they actually found is that the most successful strategy, because no change control is actually in the middle, the worst was this external CCB process, but the most successful strategy is frequent light touch peer review. So somebody literally sitting next to another developer who's familiar with the same code base saying, here are the 6 lines that I changed, can you review them for me? And then doing the same thing 2 hours later actually was the most stable process. So why doesn't this work? Well, external change management allows the entropy to remain in the system, right? It keeps the bug in the box. And it sort of instantiates this fantasy world where as long as we keep it hidden, no one's ever going to find out. But the problem is, as soon as you release it into production, someone's going to find out because people actually have to use that software. And if you haven't simulated that, if there's no way to know what's going to happen when you release it into the wild, fear is not going to help you. And it takes authority away from teams. And it reduces individual investment in work. And this is another thing this DORA team discovered, is that when an individual developer's sense of investment in their work declines, so does the quality of the work, and so does the stability of the build. But when we increase that individual investment, we allow these developers to feel like they are involved in their work and to actually take the steps required to test more, to break things more, and as a result, to fix things more. And it also creates this time lag, right? Because if you're putting all of your code in a box and you're shipping it off to this external change management group, that's time that you can't be spending developing more, testing more, breaking more, and fixing more. And it allows failures to propagate. Because as soon as you get that box back with the yes or no from your CCB, you've probably got 6 more features that you need to implement, and then you've got to merge those 2 trees together, and then your lead developer is pulling her hair out because she's got merge conflicts to deal with. So the only way to solve this problem is by failing more rapidly, is by removing the part of the process where we say this code is golden, it's good, it's going to production, and we continue making changes to it, and we attempt to break things as often as possible. But all of this is related to culture, right? Because DevOps wouldn't exist without people, and people together in a group have a culture. I like to think of this in terms of Conway's law. Conway was a computer scientist way back in the 50s who says, I'm going to step aside so I can read this, organizations which design systems are constrained to produce designs which are copies of the communication structures of these organizations. You can't just plop tools down in a dysfunctional team and expect that team to become functional. The software created by a dysfunctional team will be dysfunctional. This is actually a sociological law that has been proven time and time again, because the boundaries that are inherent in software reflect the boundaries that are inherent between people on a software development team. And only by changing those boundaries and changing the relationship of the people involved can we actually change the software that results from it. So one interesting thing this DORA team did was they correlated the performance of DevOps teams with something called the Westrom, after Juan Westrom, who's a sociologist, typology of organizational cultures. And he's got this whole theory that cultures, in particular cultures that produce work, can be divided into 3 groups, right? And starting at the bottom, at the sort of least successful end, you can have a pathological culture. Pathological cultures value power more than anything else. Messengers are shot in a pathological culture, especially if they're bringing bad news. Responsibilities are shirked, bridging between people is discouraged, and failure is scapegoated, right? It implies that there is moral value associated with failure, that we have to identify the agent who's responsible so that that agent can then be scapegoated, so that the person in power cannot be held responsible for the failure. But recognize that that involves making failure a bad thing to begin with, right? Which is not what we're trying to do with DevOps. One level up from that, you can have a bureaucratic culture, right? The highest value in a bureaucratic culture is rules. Are we following the rules? Are we hewing to the procedure? Messengers tend to be neglected because if you're saying something that pushes against the idea of the rules, it doesn't make any sense. There's no space for that in a bureaucratic culture. Responsibilities are very narrowly defined and people are expected to stick to their lanes. Bridging in these situations is tolerated, but just barely. Because if you're not sticking to your lane, then there must be something wrong. And something can't be wrong with the rules because that's the highest value, so there must be something wrong with the person. And finally, failure is treated as a source of justice, right? Well, if something failed, this person must be responsible because it can't be the fault of the rules. And again, what we see is that this is directly correlated with the stability of the software that are produced by these teams. Pathological teams whose values reflect the column on the left here produce less stable and slower software than teams on the right column. So generative culture is actually the most successful. Generative culture values performance as the higher goal. How are you helping the team? Messengers are trained. If you're delivering good news, we want to embrace that. If you're delivering bad news, we want to embrace that. We want to train you to do that more and more often because that information, regardless of what it is going to help the organization and it's going to help the product. Responsibilities are shared. If a developer is having a problem with something, the culture allows somebody else to take over and say, let me help you with that, as opposed to, wow, that's probably going to break, so I'm going to stay away from that because whoever breaks it is going to get blamed. Bridging's encouraged, right? Failure, rather than resulting in scapegoating or justice, results in inquiry, right? Which is a value-neutral term. That failure is a piece of information that's being delivered. And only as a result of looking into it as something that's value-neutral can we learn anything from it to begin with. And then finally, novelty in a generative culture is implemented, right? New ideas, if they are good, become the rules, right? And we're no longer narrowly defining our roles within the organization. So again, the Dora team found statistically significant relationships between generative cultures and stable and more quickly delivered software. Google also did a similar thing. And they looked internally at all of their software teams, from the worst to the best performing. And they had an idea. They said, well, let's figure out what an ideal software team looks like. How do we assemble it? And they actually had an idea to start with that this was a matter of practicality, right? Well, to have a good application team, you need a rockstar Node.js developer. You need a PhD in data science. You need a certified Scrum Master, et cetera, et cetera. There's no statistically significant relationship found between any of those things and high-performing software teams. What they actually found were these 5 things. They, surveyed all the people involved, and the highest-performing software teams had these 5 things to say. First of all, do the people involved in the software fundamentally believe that their work matters, right? Is the work something that they personally identify with? Is it important to each of them? Are the goals and the execution and the rules on our team clear, right? Can we depend on each other? If I'm really struggling with a bug, can I depend on somebody to come pick me up for that? Or am I going to worry that it's going to fail in production and I'm going to get blamed for it? But the number one statistically correlated factor to high-performing software teams at Google, psychological safety, which they define as, do we have the freedom to take risks without thinking we're going to be scapegoated or blamed for them? Can I do my job without feeling insecure or embarrassed if I introduce a bug into production? Again, there's an inherent contradiction to this, right? Because the teams that feel more free to introduce bugs into production are the ones that have fewer of them. And that getting our mind around that is part of what's really important about doing DevOps. Again, statistically correlated relationship with the generative culture. If failure isn't okay, then teams won't take risks and teams won't innovate. Because you need to have the capacity to fail in order to move forward on anything. And we need to accept that failure is inevitable. And that's a really scary word, right, for a lot of people. But again, we live in a chaotic universe. We can't help that. Failure is going to happen. Our only choice is whether to embrace that or whether to scapegoat it and to blame people for it. But again, that failure is always going to result in at least 2 pieces of information. Because now that you've identified the bug, A, you know how to prevent it, right? So you've got a developer that's going to be charged with fixing it. But B, you know how to detect it. And that is equally, if not more important, because you can now write an automated test to determine if that bug is going to be reproduced in the next version of your software. And if that test is good enough, you can ensure that it's not going to be. So the bug is temporary, but if you're doing DevOps right, the fix is permanent. So the more things you break, the more things are going to be fixed forever. Ideally, if you're doing it right. But sort of the ultimate end of this from a people's perspective is that the most valuable member of your team is the one who fails most often. Because they're the one who is delivering the most information back to the project, and they're identifying the most things that can now be fixed and ideally can be fixed permanently. Failing more often means that the impact of each failure is lower. Because you don't have to worry that the bug from 2 weeks ago is going to be reopened by the fix you just made to the bug from yesterday. Because you've got tests that accurately reproduce that production environment. So before that even gets to production, you're going to know whether or not that test fails. This is where we get to my favorite, the simian army. So we all know the parable of if you take an infinite number of monkeys and you put them in front of an infinite number of typewriters, eventually, over a long enough time frame, you're going to get Shakespeare, right? Which is cute, and I guess it's mathematically true. But the thing you're mostly going to get is a lot of broken typewriters, right? Because monkeys are really good at breaking things. So this concept actually comes from Netflix, who is really, far and away, I think, embraced this kind of failure-first DevOps philosophy more than any of the other big tech companies. They have a suite of tools called the Simian Army. And this is built around a philosophy they call chaos engineering. Chaos engineering is the idea that you run a variety of experiments that simulate a variety of real-world failures, right? All the things we talked about previously. Errors caused by spaghetti code, errors caused by the networking gods, by packages disappearing from upstream repositories, by connections failing, etc. You run those experiments in your production environment, and you run them constantly at random intervals all the time. If you do that, you are going to be forced to fix those problems, right? As opposed to waiting and keeping the bug in a box and hoping that nothing happens. A lot of the tools that they've released are specifically around Amazon Web Services, right? Because again, the networking gods live in the cloud and they cause havoc in the cloud. So the original tool was called Chaos Monkey. What Chaos Monkey does in your production environment at any point in the day is it will destroy an Amazon EC2 instance. It's one server, it just goes away, disappears from your infrastructure. Can your software handle that? Well, it's going to have to, because that tool is running in production all the time. They went up from there. They have Chaos Gorilla, which actually destroys an entire Amazon availability zone, meaning an entire data center just goes away. And their application has to be able to handle that. And then the one at the top of the list that I like best is Chaos Kong, which simulates the disappearance of an entire Amazon region, which is basically the effect of a meteor or an atomic bomb destroying an entire city. And their application handles that failure gracefully because they have a tool that's running in production all the time to simulate it. They don't have to wait for a meteor to hit a city and determine if their application is going to scale. It does because they simulate it every day in production. And this is the idea through which we can only fix things if we continually break them. Failures are experiments, right? If you work in small batches, you give your teams the authority. Yet again, switching windows, this is hard. If you work in small batches, you give teams the authority to make changes to their code, and you limit the blast radius of failures, right? Because this is all about managing entropy. It's not about eliminating entropy. We can never say that we've eliminated any chance of failure from our application. But what we can say is that we're pretty sure that if an individual server or an entire data center or a city that hosts an Amazon region goes offline, we'll scale. We'll gracefully support that failure, right? It's really important to ensure that teams are comfortable making those suggestions and coping with that failure. One of my favorite stories is about the birth of the recommendations engine on Amazon.com. It's this guy named Greg Linden, who was a developer at the time. He's now in senior leadership at, moved from Amazon to Microsoft. And he was one of the early developers in the Amazon shopping cart. And he had this idea that if you were in your shopping cart, maybe if you saw a feed of products that other people had bought in addition to the products that were in your cart, that would increase conversions, right? he went to his manager and said, hey, I put together this recommendations engine. I'd like to run a test and put it in production. Manager said, no, absolutely not. People are going to hate that. It's actually going to reduce conversions. Don't do it. Greg went back to his desk, pushed it into production, and he was right. It actually increased the amount of sales that Amazon got, and that's how the recommendations engine was born. And that's only because their culture, and this is way back 15 years ago, allowed him to do that. Greg didn't get fired, he got promoted as a result. But here's the thing, he could have been wrong, right? It could have actually done what his senior leadership said and decreased the amount of time people spend in their cart, right? And reduced them checking out. Would he have been fired in that case? Well, ideally no, right? Because he took a chance, he ended up being rewarded for it. But you have to have a culture that allows people to be comfortable doing that. They need to have the psychological safety to feel like they could take a risk that might result in something breaking. And so, because this is a government conference, right, we get this question, what about highly regulated environments? What about this, da-da-da? I have a change control board, I have security, I have compliance, I have FedRAMP, and et cetera, right? But the beauty of DevOps is that those compliance and change control processes can actually themselves be automated, right? You can run your code against a 508 compliance scanner. You can run your application and its infrastructure against a FedRAMP security vulnerability scanner. You can build that into your DevOps pipeline so that runs every time on every deployment, on every commit to ensure that you're never slipping out of compliance. But you have to be willing to break things in order to do that. And again, these DevOps practices increasingly means that compliance can be handled at the cloud or provider level, right? So that you ensure that if you put things in your cloud provider in a certain way, then they're going to end up being compliant. So the idea that, going back to the Netflix example, right? And a lot of this has to do with technical terms that I don't want to get into, like microservices, environments, and et cetera. But the idea of graceful failure means that a bug in production is not going to hose your entire system, right? That you can have a failure that may deliver a different experience to your user, but that can actually be the successful result of an experiment. And this, I think, was best put by the late, great comedic genius, Mitch Hedberg, who says, an escalator can never break. It can only become stairs. So there should never be a sign saying escalator broken. It should just say escalator, temporarily stairs. That is my favorite definition of DevOps. Because if you embrace the mindset that a failure is only another kind of thing, you'll allow that to happen much more often. And people will be healthier if they took the stairs more, let's be honest. All right, so finally, what are some recommendations? How do we get down to brass tacks? How do we create this enabling culture where people can break things much more often and that actually results in more stable software? Well, some of the things that the team at Dora found was you need a visible feedback loop, right? You need to ensure that management is involved and that changes can be tracked from breaking in production all the way back to your code base, all the way back to the requirement that caused the change. And you need visibility into that in all levels, right? If there's anything that's hidden, if there's information that's not being pulled into the process, then it's going to fail, and like not in a key way. You need to collect metrics not just on the performance of the software, but on the performance of the team itself. Because again, this is about people. If there weren't people, there wouldn't be any DevOps. You need to be honest about the level of technical debt, is what they found. In organizations where teams would lie or not elevate the amount of debt in their systems to senior management, we saw less stable software and also slower deployments. But if there is a universal shared understanding of the amount of technical debt in a system, you can actually fix those bugs by the kind of process we've been talking about. And again, the organization needs to value the discovery of objective data over rules, over power, over process, over anything else. If you're bringing a piece of information about your software or about the development process to a senior leader, they need to not scapegoat and not blame and not treat that as a moral failing, but rather engage in a process of inquiry to discover what that information means and how it can be used. And finally, we need to ensure that changes can be made by anyone on the team without getting bogged down in external communication, right? Without having an external change control board looking at code, without having boundaries between groups within the organization that inevitably are going to result in boundaries within our software. Finally, everything is code, right? This is sort of the core of DevOps. If your infrastructure is not committed in the same repository as your code base, you're going to end up with failures because you can have a reproducible environment, right? If it can break on deployment, then it needs to be tested. You need to have a test for it, and if the test breaks, you need to fix the test. You need to have consistent downstream local and staging environments that are exact mirrors of production. This is where we get into a little bit of a technical level, but there are tools that do this. It doesn't matter which ones you use, you just need to use some of them, right? One interesting thing the Dora team found is that the high-performing teams put all their code in one branch. Everybody shared a trunk branch. Everybody committed to it every day. This is actually contrary to a typical Git best practice, which is to branch off into features and bug branches and ticket branches and individual development branches and then try to put them all together. They actually found that more entropy is introduced when you have all these branches that are trying to come together into one than if everybody simply rebases off of one trunk branch and puts it all together every day, pushes that commit to production, and runs all the tests against it. Again, environments have to be self-service. Your developers have to be able to create an instance that is an exact copy of production so they can run their tests against it, so they can write code reliably against something that's going to mirror the production environment. And then there's this idea of a loosely coupled architecture, right? And this is how Netflix is able to use the escalator model. If something breaks in the, you might also like engine on Netflix, your entire experience doesn't go down. You just see a different block in that space, right? Because their architecture is smart enough and self-healing enough to know what to do in that situation. But that only happens when you decouple the architecture. You do something like headless Drupal, for example, and you have services that can each independently fail, but the application, the other services in the application are smart enough to be able to handle that. And finally, all of this only works if everyone on the team is able to break things. If there is a boundary in your organization between people who can push stuff that's potentially broken into production and the ones who can't, that boundary is going to be reflected in your code, and it's going to result in less stability and less frequent deployments. So that's what I have to say. Thank you, everybody. Any questions or want to chat? No? Yeah?
Does it have to be production? Can it be like a secondary environment that goes through a test?
Sure. So yeah, the question is whether this testing has to happen in production. Ideally not, right? Ideally, you have downstream environments that mirror production to such a confident degree that all these things get caught before they're broken in production, right? But in order to get there, you have to allow for the failure to happen upstream. And that's, I think, the real principle of chaos engineering, right? Is to say that in order for us to write software that allows an entire Amazon region to go down and still be healthy, we have to simulate that at the production level. Because otherwise, nobody's going to write code that does that, right? Again, it's about opening the box and allowing yourself to see the bug. Because otherwise, you can keep that tucked away. But then a meteor is going to hit Boardman, Oregon, and US West 2 is going to go down. And if you're only in that region, and if your application doesn't know about anything else, then, well, that's not going to be happy times, right? But the idea is that if you capture all of that, it's all in code, it's all committed to a repository, and it's version controlled, then you can create an infinite number of environments that are exactly the same as production. Obviously, that involves tools like load testing, like Locust and things like that. Because one thing that is special about production is that your users are using it, right? There's traffic on it. So if you can simulate that, in addition to the code being the same, the database being identical, et cetera, then you can be pretty sure that you're going to catch something in staging first. But I really do think that that only becomes possible when you admit to the idea that, like, yeah, it could break upstream too. Anything else? All right. Thank you, everybody.